everybody. Mr. Milks here.
And MoNaCo is too.
We are in our second homework video in our 10th unit of study.
Page 4 and 5.
And as always, second video is what vocabulary is going to be testable.
Yeah, so guys, take the notes, study it up, and take your vocab quiz. Let's not wait till the end on these
In
things.
this vocab quiz, we actually put a couple acronyms and mnemonic devices so that you can actually remember some of the concepts.
And we're going to use them. I'm going to tell you right now, oil rig is one I use all the time, and I cannot do these problems if I don't write oil rig on the top of my page.
I don't remember it, yeah. So the first vocabulary word you get new is reduction. It's when an atom gains an electron, the oxidation number reduces. It gets lower.
You're right, and we've done this with ions back in the day.
Mm-hmm.
Oh, you're going to show us?
I'm going to just do a real quick one. So when an atom gains an electron, like if I got lithium and I add an electron to it, it becomes lithium -1.
So I went from an oxidation number of 0, and it reduced. It went smaller.
Reduction.
Okay, good.
Okay,
And
hands up.
Yeah, so it's going to, remember, it's backwards, and we already did it before, so we're not going to go back and relearn it all, but we're going to use it. So oxidation is when an atom loses an electron, the oxidation number now increases. So it's going to become more positive.
For example,
When lithium loses an electron, it becomes a positive ion.
which shows you lithium is becoming an ion and the electron. So it becomes increased positive numbers.
So this number is what we're talking about. Increase.
Right.
Good.
Very good. Now, it's a little mnemonic device. I'm going to let you do this one, because this is the one you like.
Leo, the lion goes grr. Losing electrons is oxidation. So if I lose an electron, oxidation has occurred. Gaining electrons is reduction. If I gain an electron, reduction has occurred. It's a device to remember what oxidation and reduction are, period.
Right. And there's another device to learn the exact same thing. This is the one I particularly use, oil rig. Oxidation is losing electrons. Reduction is gaining electrons.
Right. And so notice oil rig doesn't have the key term electron in it.
Right. It just makes it understood that you're gaining or losing electrons to form ions.
Leo Gurr has the word electron in it, which is why I prefer it, because it reminds you that we're talking about electrons here.
There you go. So I think that we're both under the premise that you guys pick whichever one works for you.
And stick with it.
And go with it. We're cool if you use either one. Okay? Oh, here it goes.
Oh,
All
hate
right.
these milks. You better do these ones.
I'll do these. Don't
Okay.
worry. I'll do these ones. All right, so first off, reducing agent. This is the species responsible for the reduction actually being oxidized.
And when you say species, we mean element.
Yeah, well, it's just the way we say it. So it's the thing in the chemical equation that is responsible for the reduction. Okay, and those are generally some sort of elements. The oxidizing agent is the opposite. This would be the species that is responsible for the oxidation, so it's actually being reduced.
Because if you lose electrons, somebody else has got to pick them up. Because these things play mutual, spontaneous, and
Equal and
opposite.
opposite.
So that's why.
If I lose 2 electrons, somebody else has got to take 2 electrons.
Maybe we could act this one out with people and balls of
Yeah.
paper. If you ask in class.
Well, to be honest with you, we could actually rebalance equations, and I don't think that we even went that far with this unit, but we could.
Carrying on. Oxidation numbers, the charge on the ion after it has gained or lost electrons. We have called this the ionic charge. We have called it the oxidation number. We've called it many things. How many did it lose? How many did it gain electrons? But the charge of the ion is technically the oxidation number, and it says it on your periodic table's key. But if you didn't understand that, here it is.
The +1 is the oxidation number. It's the charge.
The +1, because we have lost 1 electron.
That's what we got to not get confused about. You guys can't be saying that that's gained an electron, because the electron's charge is negative.
Correct.
Okay? Half reaction. Half reaction is when I write just the oxidation or the reduction reaction, and I include the number of electrons I've gained or lost.
Right.
I'm not going to write both. I write one at the time.
Right.
Okay? That's a half reaction.
We're going to decipher a whole equation to write both half reactions from it.
Right, and then we can balance, but here we go.
A voltaic cell, my favorite. It's a cell that spontaneously converts chemical energy into electrical energy. It's any dry or wet cell battery that produces electricity. It's the reason why Mr. Milk's clicker's working. It's the reason why these headphones are recording audio. It's the reason why my cell phone is going off in my pocket. Carrying on.
Electrolytic cell, very similar, but it's different because it's not spontaneous. So I need to have electrical energy in it to make it go.
Right.
There's the hint. Electricity is required. Can I draw the battery symbol right now?
You need a power supply, yeah. There's many ways to draw batteries, but physics-wise, it's alternating short and long lines. That is related back to some history. I'm so glad you put that out there.
Oh, boy.
It's for the guy who first created the battery. It was called a galvanic pile, and it was alternating long and short discs of metals with an electrolyte or salt solution in between them, and it spontaneously produced a voltage. So that symbol, short, long, short, long, short, long, means a power supply or a battery, and it's a heritage symbol back to the 1600s, I think, when they first started making these galvanic piles.
I'm throwing that in there because real quick, when you see a picture of any of these things, if you see that symbol, you know it's an electrolytic cell.
Mm-hmm.
Okay?
Now, an electrode, we've used this word a long times here and there around the world, but an electrode is a conductor that connects with the non-metal part of the electrochemical cell.
Yeah, it's like the metal tip.
Yeah.
You know, it's going to look a little bit like a
Battery in a car has two electrodes, a positive and a negative sign.
Right.
The battery that you plug onto your cordless drill, if you look carefully, there's two little lines,
a lot of
positive and a negative.
Terminals.
Terminals, yes, exactly.
Because that's where it ends.
That's
where the metal piece ends.
The two flat parts on an outlet are the electrodes. The little circle, that's your ground. So any outlet, those are your electrodes.
Right.
That's where you connect your positive and your negative.
And then these electrodes have specific names. The first one's called the anode. And what you need to know is that is the electrode where the oxidation takes place.
And oxidation is losing electrons. So these terminals are negatively charged.
Usually.
Usually negatively charged. So I'm going to put a negative sign there.
Right. I specifically didn't want to put a negative sign there for a reason.
Oh, what is it?
Well, it switches the electrolytic cell versus voltaic cell.
Really? Does it?
Yeah. The
I
oxidation
must
always
not have
takes
paid
place.
attention.
Yeah, it's okay.
I remember anode because it's a negative, A-N, a negative node. It's the negative side of your battery. So the negative battery on any battery you see in your pocket is the anode. Because, again, we have voltaic cells in our pockets, not electrolytic cells.
And let's be honest, the most of the things we're going to see is voltaic. So I'm cool with it. I'm cool with it. And
so that
cathode, it's got a T in it. But first of all, it's where the reduction takes place, and that T looks like a little positive sign, and so you remember that the cathode is the positive of the electrons.
So everybody knows batteries got pluses and minuses. Now you know what they're properly called.
Right. And you know what's cute is that they're really close to anion and cathode.
That's exactly why they're named anode and cathode.
Oh, kidding.
Anodes, anions, negative. Cathodes, cation, positive.
And we have a mnemonic to help you remember specifically that.
So, anode is where oxidation takes place. Anode, ox. An ox. Grammatically, it's a correct statement. I have an ox in my backyard.
Yeah, you can't have an and cat. You have a cat. You don't have an and cat.
No, I don't have an cat. I have a cat.
Correct.
Mm-hmm. His name's Dexter.
Oh, nice. Mine is Saber.
Saber?
Yeah, he came with that name, so we just
kept it.
Becca didn't want to change it, so. Reduction happens at the cathode.
Yep.
Red cat.
Yeah.
Some people have red
I've never
cats.
seen a red cat.
Well, like a tabby cat, so like that's an orangest cat.
My Dexter's pretty orange, so I
He
guess
is.
maybe he's red-haired.
I guess, yeah.
You don't have red-haired
You have an Irish
oxes. Yeah.
So salt bridge, this enables the ions to flow between the oxidation and reduction half cells in that voltaic cell. So when we get the electrons going, you're going to see I can't make it go all the way around without this salt bridge to let the ions themselves go.
Completes the circuit.
It does.
So there's a counterbalance. If electrons are flowing in one direction,
It's got to make ions go in the other.
back in the other, because otherwise it's not a complete loop.
Right, and it's a repulsion thing. So electrons are negative, so doesn't it make the positive ions go to the other side?
Yeah, but the negative ions move to counterbalance. So the point is it completes the circuit.
Well, that's what I meant.
Your salt bridge won't.
I got it
If
back.
you don't have a salt
Repulse the
bridge,
negative, right.
the battery ain't going to work. So if
Right.
you've ever found a dead battery out the package, Maybe there's a manufacturing defect in that salt bridge with inside there. Maybe it's not working properly.
There you go.
Either way.
Spontaneous. This is a word you might have heard of before, but in chemistry it's got a little bit different of a connotation to it.
So it's a reaction that goes all by itself with no extra energy required to make it go.
Right, and it kind of works with our previous conceptions of what spontaneous is, because to me that means instant.
Right, so any reaction that happens without me having to heat it up
Would be instant.
would be spontaneous.
Right.
Your bike chain, I left it out in the rain last night. It came out this morning, it was rusted. I didn't do anything to make it rust except leave it outside. That's a spontaneous
Right, I didn't add any
reaction.
energy.
I didn't have to. The universe added the energy
Right, but if
for
you're
me.
gonna like gold plate a penny,
Oh yeah, got to do something about
I
that.
got to give it some juice.
For sure.
So
Or if
that-
I'm trying to start a fire, a campfire, I have to heat it up to get it to go.
Right, so that would be a non-spontaneous reaction, one that requires energy.
To get it to go. And from our previous unit, the kinetic energy and kinetics and equilibrium, the activation energy.
Yeah.
A spontaneous reaction has a very low activation energy, so it goes automatically by itself. A
Yeah.
non-spontaneous reaction is like a reverse, where you've got to pump a ton of energy into it just to get it started.
Right. Really what it is. And then specifically anions and cations.
Anions, atom is gaining an electron, and it's a negative ion.
Ooh, we've done these.
So many.
And cation, again, it's got a T in it, positive. An atom that has lost an electron, so it is now positive.
If you're having trouble with what the charge on electron is and the symbols that we use all year long ain't helping you, memorize anion and cation, because that tells you right then in there in the definitions what charge an electron has and what charge an atom or ion becomes if it loses or gains it.
Right, and then it also helps us with the anode and cathode.
Yeah, for
So
sure.
it all
Really.
ties together. Really all does. So here it is.
Know your vocab.
Study,
These are
take your
keywords
quiz.
that will be using this unit. No shame in just watching this video and then coming in and do your vocab quiz. Do it. Crank
Yeah,
it. Get it out the way.
seriously.
Moving on with ourselves.
Turning it in. I got 16 right.
See ya!